Hi, this is Miss Becky again, and today I'm going to be going over section R4. At least it currently is R4 on IXL. Again, this is for IXL, section I4 in Precalculus, Precal. And this video, what we're going to talk about are coterminal and reference angles, and that's going to be using degrees as well as radians. And again, radians radians are in terms of pi, so you'll see pi if you remember that. So the first thing I want to talk about are the standard position of these angles. They start off, a standard position is starting off at 0 degrees and moving counterclockwise. The terminal uh, part of the angle is where it ends, terminates. Um, so this is a standard degree angle right there. Now, coterminal angles, you can go, this angle opens up 120 degrees, positive 120 degrees, counterclockwise. But you can also get to that same position by going clockwise, which is a negative angle. So coterminal angles just end up or terminate in the same place. So we just need to be able to figure out what the degree is that completes the cycle of 360 degrees. So just to review, I put these on the grid. You don't have to. This IXL doesn't. Sometimes it helps to visualize, especially for me it does. So right here we have 0 degrees. Right up here, we have 90 degrees, then we keep going over, we have 180 degrees, 270 degrees, all the way around to 360 degrees. They want us to find a coterminal angle that um, is with a 285-degree angle. So the first thing that we're going to have to do is find out where that 285-degree angle is. Well, obviously, it's going to be past the 270 degrees. And you can simply use some math. So if we take the 360-degree angle and we subtract the 285-degree angle the 360 complete circle, subtract the 285 degrees, and that's going to leave us with 75 degrees. So each quadrant is 90 degrees, and you don't have to be precise, so I'm going to guess that it's somewhere around there. And then I'll draw my angle. So this right there is a positive 285 degrees. Now we've got to find the negative angle right here. Well, we've already said there's 75 degrees left, so negative 75 degrees would get us in that same position for the coterminal angle on that one. All right, moving right along. They want us to find a coterminal angle with a positive one for a negative 241 degrees. So we're going to be drawing our angle. Now we can label this differently. So this would then be negative 90 degrees if we're going clockwise. Well, it's going to be negative 180 degrees. And then up here, we'll have our negative 270 degrees. And then our negative 360 degrees would bring us all the way around. You just have to figure out where that's going to be. It's not going to come all the way up to 270 degrees, and it's going to pass the negative 180 degrees. You can use your math to figure out like what's left over. 360 degrees, take away the 270 degrees. It's going to give us 119 degrees left over. All right. So we can draw that, I'll estimate it right there. I'm going to say that that's good. That's our negative. Um, oh wait, shnikes, guys, I did that wrong. I don't want that. We're doing a 241 degree, 241. Did not mean to do that math right there. That's okay. We need to find out, well, actually that does help us. Okay, that's how much we need right here. So if you're going positive in a positive direction, yeah, I'm right. That's going to be 119 degrees. So you're just trying to figure out like what is left over that would make up the complete 360-degree angle. All right. Right. Example number 3, we need to find a coterminal angle, a negative angle, with with an angle that has 8 pi over 5 radians. It's a radian angle. So we're not using degrees. If you remember that over here at 180 degrees, that makes 1 pi. So if an angle goes all the way around over here, pretty much straight line, that is 1 pi. If you continue round to the full circle, that makes 2 pi. Now, this, the easiest way that I've found to do this is for 1 pi, we can divide it up into fifths, since that's what we're dealing with. So 1 is the same thing as 5 fifths. So this is 5/5 pi right here, all right? And now fifths are a little bit harder to deal with. Let's see. I'll show you what I did. Hang on. Behold my wonderful artwork here. I know it looks crazy, but like I was saying, I divided this up. I mean, 1 pi is the same thing as 5/5. Again, I renamed it as 5/5 because we're dealing with fifths, so it makes it easy. You go all the way around, we have 10/5. That's the same thing as 2, because if you remember, 1 pi here, 2 pi here. All right, so I've gotten rid of that black line because I wanted to divide the 180 degrees here up in fifths. So this first section is 1/5. So it would be like 1/5 pi, 1 pi over 5. And we don't write the 1 next to the pi, so it's just pi over 5. Here's our second fifth, so it's 2 pi over 5. This is our third fifth, which is 3 pi over 5, 4 pi over 5, 5 pi over 5, which is the same thing as 1 pi, 6, 7, 8, 9, 10 of them. This is just the easiest way for me to be able to um, figure these out. So we want to, we have a positive 8 pi over 5. So we would go all the way around to 8 pi there. There's our positive angle. And we just have this much left to, so from here to here, that only leaves us with 2, 2 pi. So a negative 2 pi, 2/5 pi, that's going to be the negative coterminal angle there. That is the other reference angle for that one. Okay, for the next one, we need to find a coterminal angle that's positive with the negative 9 pi 9/8 pi, or 9 pi over 8. Now it's negative, so I marked it. We're moving clockwise. All the way to 1 pi, it's going to be a negative 8/8. That's the same thing as 1 pi. So I just renamed it in terms of eighths. So half of that, which is half of a pi, is going to be down here, negative 4/8 pi. So that's half of it. And each quadrant I have divided up so nicely into 4 pieces. So this is negative 1/8 pi, because the whole thing is right over here. So this whole section, these two quadrants together, have to be divided up into eighths. That's negative 1. This is negative 2 pi eighths, and so on. What we want to get to is 9. So down here are 4 of them. Over here is 8 of them. And then we get right here, that's going to be negative 9 pi over 8. So our negative angle would go around like this. And how many does that leave us for the coterminal angle? All right. Well, it's 16 to make the full 2 pi here. So that one is 7, positive. A positive 7 pi, 7/8 pi. In this direction, the 7/8 plus the 9/8 total to the 16 eighths, which is going to make up the whole thing. Okay, hopefully that makes sense. All right, for the next examples, we're going to be figuring out how to find the reference angle. And what that is, reference angle is always positive, and it all is always less than 90 degrees. So we need to know what quadrant that the angle terminates in. All right, so if you're right here in the first quadrant and you have an angle that looks like this section right here is the reference angle. We want to know how far is it to get back to the x-axis. We only care about this angle right there. And then the second quadrant, the reference angle, if your angle comes over here, it terminates here. We're only concerned with this portion of um, this angle, the measure of it, to get back to the x-axis. It's always the x-axis. Down here in the third quadrant, if your angle terminates down here, we want to find out what this measure is back to the x-axis. Fourth quadrant, same thing, up to the x-axis. So we'll go over some examples. All right, we're going to find the measure of a reference angle for a 260-degree angle. You don't have these graphs, these grids for IXL. It just looks like this. So you can either jot it out if you're draw it out if you're visual, or just do the subtracting like I'll show you in just a second. So we need to determine which quadrant the angle terminates. So obviously we're going to go all the way over here. It's going to be 180 degrees. Then we need to get to 260 degrees, which is just shy of the 270 degrees. So I'm guesstimating about there. So we continue all the way around to, we'll call it 260 degrees. All right, now we're going to calculate how many degrees from the terminal side to the x-axis. Well, that's going to be this amount right here. When we, if you draw, an imaginary perpendicular line here, what happens is we've got that right triangle, and that's what helps us. That's what the reference angle is for. So we want to know how much to get back to the 180 degrees. So we will take 260 degrees, subtract the 180 degrees, and that leaves us with 80 degrees. Right, so that's your reference angle, is 80 degrees. Alrighty, let's move on to the next one there. This is a really big angle. We want to find the measure of a reference angle for a negative 780 degrees. Since it's a negative angle, we can just calculate. Every time around is 360 degrees. So we have 360, another 360 around. That's horrible writing. Gives us 720 degrees. So if we go around negative direction, there's 360. There's 720 right there. Now we need how many more? We need 60 more degrees to go out. Let's see, pick that color. So that's about there. We'll call that 60 more degrees, then would take us right there. So there is our negative 780 degree angle. But again, The only thing that we're really concerned with is this portion right there. How big is that between the terminating side and the x-axis? So you can just simply 780 degrees subtract our, what was it going to say? 720 degrees. Where did I get 720? Hang on. I confused myself. The 720 was the two complete full time around. So you take the 780 degrees, subtract to find this difference right here, and that's just 60 degrees. So that would be your reference angle, this part right there. That's all we're worried about. All right, now this one is in terms of radian angles. It's negative. So I labeled the this, I labeled it counterclockwise, negative. And I did in terms of eighths because that's what we're dealing with. So 1 whole pi would be at the 180-degree line over here. And so that means from 0 all the way over here to 180 degrees, or 8/8 pi, that's all split up into eighths. So we just need to go 9 of them. So we go follow down here, there's 4. Over to here, there's 8. I'm just estimating that right there is going to be my 9th eighth. Okay, so that's a negative 9/8 pi, 9/8. And for reference angle, we're only concerned with how many degrees between that terminal side and the x-axis there. Well, it's pretty easy to figure out. So 9/8 subtract the 1/8, 9/8 of pi, subtract the 8/8 leaves us 1/8. And you put the 1 in there for Excel or anybody else, they're not going to like that. So that would be your reference angle right there. All right, just in case you need any more examples without all the graphs and everything, here is a 672-degree angle. If you need to write down, like, 1 time around is 360, 2 times around 723 is 180, because we're only concerned about, we don't care how many times that we go around, we just want to know where we end up. So with 672 degrees, when you start taking away complete cycles, 360 degrees is going to leave us 312 degrees. Well, I know that's in the 4th quadrant right here. We want to know how much is left over. So we take the x-axis here is 360 degrees. Take away that 312, and that would leave us with 48 degrees right there to get back to the x-axis. That's our reference angle. So pretty much the angles that we're concerned about are the leftovers. That one, this one, this one, right? So this was 490 degrees, but we start taking away the 360 degrees, and that left us with 130. That's over here in this quadrant. And we're only concerned about getting to the x-axis. So 180, take away that 130 degrees, gives us a 50-degree reference angle. And the same thing over here. We have oops, we'll make it 540. Yep, 540-degree angle. And we start taking away the 360 cycles. That leaves us with 185, which is going to put us over here in the 3rd quadrant. And that's going to leave us with a 5-degree reference angle. So hopefully that all makes sense for you guys, and you'll do fine on that section, I believe. See you next time.